So we do have to do something today. So let's get started with going over the homework. So we learned about unconformities at the beginning of yesterday, just that buried erosional surface, a gap in the geological record. What can we say about unconformities? They provide evidence that, what did you guys say? An unconformity is literally, that's all it is. It's erosion has happened. It has destroyed part of the rock record. Oh boy. Which rock formed most recently? With this, it's probably best to look at the answer key first before you just randomly say which one was most recent. So they did give, this was answer A, the limestone. This is answer B, the siltstone. C is the shale. And D is the gabbro, which is here. So they're asking which one formed most recently, A, B, C, or D. What do you guys say? What is it? D. It is D, formed most recently. B is this answer down here. So it wouldn't have been B because A would be the oldest, B would be the second oldest, the siltstone. Why is D most recent? Because I would feel this would be more of a short answer than a multiple choice, or maybe a multiple choice followed by a short answer. How do I know that D, which is the gabbro here, formed most recently? What did you say? Contact metamorphism, but let me warn you, if this was a short answer, I need more. What about the contact metamorphism? You're right. That's the answer. I know you know what you're talking about. No, so what they want from you is that there is contact metamorphism on all the other layers. So we know that the gabbro is younger than the limestone because the gabbro burned the limestone. We know that the gabbro is younger than the siltstone because the gabbro burned the siltstone. Same deal, it's younger than the shale and the sandstone on the top even. Because we know it's younger because it burned or did contact metamorphism on all the other rocks. So I do caution you, I knew Cam knew what she was talking about when she said contact metamorphism, but the Regents will require a little bit more thought into that. What about the contact metamorphism? There's contact metamorphism on all the other rocks. All right, that was not part of question 2, but it was good review. So which of these events occurred most recently at this location? Again, instead of just diving into the picture, I think it's best to look at the 4 answers first. So is it the faulting of B, C, and D and E? Is it the intrusion? Is it the formation of the limestone? Or is it the metamorphism of the granite? So I actually like to do, could the faulting be the youngest? Is faulting younger? Is it one of the most recent things, the faulting? Or is it the intrusion? Let's look at that. Is it the intrusion or the fault? Which one's younger? The fault's younger. How do you know the fault's younger? Because it cut the intrusion. So I know the intrusion is not the youngest. Is the formation of C, this limestone layer, is that the youngest? No, because it's down below all those other things. Is it the metamorphism of the granite down here? No, because again, that fault was younger. So could it be the faulting of B, C, D, and E? Yeah. So you do have to go through all of those sometimes. And then finally, which evidence indicates there's a gap in the geological record of this cross section? Which one is a gap? The unconformity, which is answer D, a buried erosional surface. Oh, we did not. This is actually what we're going to do today. Were you guys able to figure out which one of these was the youngest? It takes a lot of thought. So let's look. Is it D? Could D be the youngest? You did this wrong. So let's walk through it. Where do we usually look for the youngest? At the top. So let's start at the beginning. Is A the youngest? It's at the top. No. Maybe let me go back okay, let me go back a step. This, in the reading, it says, the diagrams below represent layers of sedimentary rocks from 4 different locations. 4 of the layers are identified as A, B, C, and D. No layers have been overturned. What they did not kind of imply is that, yes, these were 4 different locations, but it would be like, okay, I dug this one up over in Arcade, this one in Yorkshire, this one in Delavan, and this one in Machias. So the same general area, but slightly different spots. So what it's saying then is, okay, if there was an ocean covering Arcade, odds are there was an ocean covering Machias. If it was tropical in Machias, it's going to be tropical in Arcade. What they're saying is these are 4 very similar places. What could be different is, okay, there's a creek running through Arcade. That could have wore down some things that didn't get worn down over in Delavan. So these are 4 similar areas. So if you notice here, A, yeah, it's on top, but is it on top in all of them? In fact, A, we know that A is automatically older than C. So we can see that A is not the youngest. A is older than C. So it's not, oh, and these are out of order, but it's not answer A. Then we look, okay, could it be B? There's B, that's the only B. But one thing I want to show you is this fossil. What do we know about this fossil? We, by the way, have not done this yet. That fossil shows up actually 3 times. It's an index fossil. What did we learn about index fossils? Okay, so we'll skip this one for now. So we're going to skip this. We'll come back to this in a couple days. Let's move on to 6. By the way, if you wanted an answer, it is D. So answer A, which is D. Yeah, the regions won't be that confusing. It'll go in order A, B, C, D. That's just my computer program scrambling it. Anyway, moving on here, which one is the youngest? Is it A, B, C, or D? What did you pick? It is A. That is just a flat out extrusion. It's on top, all of that good stuff. Now, one thing I want to point out is they say the next question is which event occurred most recently? When they say most recently, are they talking about the youngest or the oldest? That's the youngest. That might be one thing you want to do when you're reading these is, yes, I know you know what most recent means, but I know you know that youngest is easier to think about. So just get rid of confusing wording and change it to words you understand. So is it the fault? Is the fault the youngest thing on here? No. How do you know that this fault is not the youngest? The intrusion did not get broken. So the fault has to be older than the intrusion. So could it be the intrusion? Yes, it could be. Could it be the deposition of sediments for rock layer A? Is rock layer A younger or older than E? How do we know? So TJ, don't answer. How do we know that A is older than E? Again, full, complete thought, not just what about the contact metamorphism? Yes, the contact metamorphism of E touches A. So it is, we know that A was sitting there hanging out and then it just got burned by E. So A is older than B. And could it be the sedimentation of D? Absolutely not. That's at the bottom. It is, oh, it is answer B, the formation of the intrusion. How do you feel with that kind of stuff? It'll take, if you notice, we're not gonna do them all today, but we got lots of practice talking about what's oldest and what's youngest. So on that note, we were working on page 19 yesterday. Don't express your enthusiasm quite that strongly, Cam, or it might make you do even more. I would want to keep you happy, so if they make you happy, I'll do more. We did page 19 yesterday. We put these events in order in which they happened, which means putting them in order from oldest to the youngest. So we did that by, if you remember, we went ahead and had some fun coloring. We cut them out. We saw that the conglomerate was at the bottom. It's the oldest, then shale, then the sandstone, then the siltstone, then the limestone, then breccia was there. Then the intrusion plowed through and it burned all of them. That's how I know the intrusion's rather young. And then the fault was the final thing that happened, and it ended up looking like this. So the fault was the last thing. But as you notice, that only filled out half the chart. The other half of the chart asks you what happened, the event, and the environment in which it formed. Here's where we need to break out our chapter 3 rock skills. So everybody grab your reference table. Oh, I saw some nervous looking faces. Grab your reference table. We're going to bring back chapter 3. So when it says event or environment, this is really just saying how did it form and where did it form? Or where did it happen? So it's asking you how conglomerate formed and where conglomerate formed. So we're going to be pulling back knowledge from chapter 3 and chapter 4 for this. So let's start with conglomerate. First of all, what kind of rock is a conglomerate? Sedimentary. So we're going to, Colton, stay with us, okay? Put that away, grab your packet. We're going to grab our reference table and we're going to remind ourselves how sedimentary rocks form. So in case you forgot, you find sedimentary rocks. You go backwards. They happen when sediments get deposited, buried, compacted, and cemented together. So we know that that conglomerate formed when sediments got deposited, buried, compacted together, but that's not all they're asking. They're also asking where. Guys, from last chapter, chapter 5, the weathering and erosion, where did we talk about, where did most sediments get deposited? They're absolutely on the surface of the earth. But what agent of erosion was doing the most work and moving and depositing the most stuff? Water, running water. So sediments were mostly getting deposited when that water slowed down. And where does water slow down most of the time? Like the biggest, most abrupt slowdown? When it hits an ocean or a lake. So we've got running water rushing, carrying sediments, and they get deposited in the ocean or the lake. Now, different size sediments get deposited in different places. Heavier and bigger and more dense. So the bigger, heavier, round ones got deposited first. So we have to kind of take this apart bit by bit. So we already established they get deposited, buried, compacted together. But we just said sediments. Specifically, what kind of sediments is conglomerate made out of? So find conglomerate and tell me what kind of sediments conglomerate's made out of. When I'm done, that was yesterday's work. We're moving on. Pebbles, cobbles, boulders, sand, silt, and clay. So conglomerate is made of a mixture of sediments. So this is what we call, actually, more importantly, it's large sediments. So those large sediments, the pebbles, cobbles, and boulders, got deposited, buried, and compacted. I don't have room to write all that, so I'm just going to say deposited. Where would those large sediments get deposited in a lake or an ocean? Definitely the bottom. But what I'm getting at is they're going to be deposited in shallow water. So remember, because they're large sediments, they're going to get deposited first. And that's typically where the ocean or the lake is shallow. Now we're going to do the same idea with shale. So again, what kind of rock is shale? Shale is another sedimentary rock. So it's made when sediments get deposited, buried, compacted together. Specifically, what size sediments are they? Clay. Is clay a big or small sediment? Small. So we do, instead of just saying large, we do say clay-sized sediments. And they get deposited. Where does clay get deposited? Because it's a teeny tiny particle. Yeah, so those tiny particles, remember when I gave the example of my tiny daughter going down the water slide? She went way far out in the pool. So small sediments get deposited in deep water. So we have to do this with all of them. So we go through. Let's take a look at sandstone, which is the next rock. Again, it's another sedimentary rock. What size sediments does sand have? Or sandstone have? Yes. So it's going to have sand. If you want to skip the size sediments and just say sand, that's fine with me. Sand gets deposited. Now we got to talk about where the heck sand is going to get deposited. Is sand a small or a big sediment? It's in the middle. So it's going to get deposited where? In the middle. When we don't know exactly where, we just say in water. So sand deposited in water. I will give you the heads up that they really only care that you know that the big ones get deposited in shallow water and the small ones get deposited in deep water. Everything else we're just going to say gets deposited in water. What? Yep. How about siltstone? What's that made out of? Silt. And again, silt's in the middle. It's not the smallest. It's not the largest. So we just say, again, silt deposited in water. Limestone's a little weird. So limestone, again, is another sedimentary rock. So it happens when sediments get deposited, buried, compacted together. But what is limestone? It's not made out of limes, I promise you that. It is calcite. Now, how big is calcite? Or very coarse. What does it mean when a sediment is very coarse? It's big. So this is either a really tiny or a really big or anything in between. So again, we don't know. So we just classify this as calcite. Sorry if I can spell. So because we don't know exactly how big this calcite is, we just keep it simple and say it's deposited in water. Check out breccia. Pebbles, cobbles, and boulders. What are pebbles, cobbles, and boulders? Large sediments. And where do large sediments get deposited? Shallow. Ooh, the intrusion combined with contact metamorphism. How does that form? An intrusion. Is it a sedimentary rock? Intrusion. What kind of rock is an intrusion? 3 options here, peeps. What kind of rock is an intrusion? Igneous. How do igneous form? When magma solidifies. Where did this magma solidify for an intrusion? Inside or underground, inside Earth. So if it's an extrusion, you'll change that up to say outside of Earth. How does a fault happen? Yes, when somebody makes a mistake. How about the fault in earth science? And just say a fault happens with plate tectonics. How about erosion? How's that one happen? We don't remember, erosion's not the same as weathering. Can just say 5 agents of erosion. So whether it was a river or a glacier or wind or mass movement, they all just move sediments. So this, you will need to pull this out from chapter 3 and chapter 5 to be able to do this. We're going to practice this some more tomorrow. As you can see, the next few pages have some more cross sections that you guys will work with and try and figure out which one's the oldest, youngest, etc. We have one more thing that I want to do today, but it's not that big a deal. I'm going to give you back your assignments that you were supposed to do that day I was absent. I decided that if you did not write down gibberish, so it actually looked like you tried and completed it all, I gave you 100. If you BS'd your way through, like writing the Gettysburg Address down as answers, you did not get credit.
If you couldn't.
I just, you know, I got to think about it.
I swear.
But you two wouldn't sit next to each other.
Yeah.
You didn't sit next to each other, I would have no problem. You can see if it fits on there. I don't know.
It's a C-type one, so I don't think.
No, so then I don't, I'm sorry.
Computer charger.
My computer charges are only the simple ones. Sorry. No, we thought we're going to go over it. You did not do it, you left most of it blank. Yeah, just like in between classes. Did anybody have this and did not turn it in that would like to get some credit? So if you did not get a grade, that means you got 100. Because you did it, you at least put in effort.
I think I was pretty over.
On the questions you did.
I didn't know I could do it.
Just blank, dude.
Cause it was like a whole week ago.
All right, let's go through these real quick so that you have, okay, back, guys, back here. This was, as TJ said, this was from a week and a half ago. It was a long time ago. I want to make sure you guys are good using that reference table. It was pages 8 and 9 of the reference table because we're going to have a quiz on Friday for pages 8 and 9 of the reference table.
Do we use the color box?
Sure.
Yeah.
So let's make sure you got the right answers here. So hopefully you did all of the highlighting amazing. The first thing you had to write was number 8. That should have been the Phanerozoic 542. Guys, check your work. If you didn't do it, change it. Number 10, Precambrian 4,600. Number 11, 542. Number 12, all you had to do was subtract those two numbers and you should have got 4,058. Yes, ma'am. You should be exactly on. There should be no wrong answers here. What number did you pick? Okay, so I know what you did. So you said that the end was right here at 500, which this black line is a little below 500, and in fact, it's 542. Okay, so that would have been this. Did you have 500 here? Or did you put 542 there? Okay, so that was what you did wrong. Then number 13, the 2 eras in the Precambrian, Archean, Proterozoic, and the 3 in the Phanerozoic, Cenozoic, Mesozoic, Paleozoic. On the top here, the 3 eras of the Precambrian. So they're divided into periods. So here we have the eon, the eras, and then the periods. Each one of those eras are divided into early, middle, and late. Then this stuff was straight off the reference table pretty much. When did it begin? 4,600 million years ago. When did it end? About 2,500 million years ago. Which, how long does it last? You subtract those two, 2,100. Am I good? 2,500 is the beginning of the Proterozoic. It ended 542, which means it lasted 1,958 years. G, the beginning was 542, the end 251. That means it lasted 291. What are we getting wrong, guys? So right here, the Paleozoic, it began right here, and it ends at 251. Then you just had to subtract those two. The Mesozoic began in 251 million years ago, ended 65.5 million years. How long did it last? 185.5 million years. Cenozoic, 65.5 million years ago. It didn't end yet, so it goes till today. It lasted so far 65.5 million years. When was the origin of Earth? 4,600 million years ago. This table was literally copying that information onto the table. So 2,500, 542, 251, 65.5. 542, 251, 65.5, 0. 1,958, 291, 185.5, 65.5. Then you had to do the percent, which I left directions on the board. That would be 43%, 6%, 4%, and 1%. You needed that information to fill in this chart here. This was all on the board that day. So what you should be noticing is that the Precambrian, which is the Archean and the Proterozoic, takes up almost all of Earth's time, leaving only a little bit of time for the Paleozoic, Mesozoic, and Cenozoic eras. So the longest was the Precambrian, and it lasted 458 million years. All right, we got to kind of speed it up. 17 is 4.6. What event occurred 100 million years ago? The first sexually reproducing organisms. Then we have 200 million years ago, the late Archean and the Precambrian. Cyanobacteria produced the oxygen. Iron oxide was on the ocean floor. This is all straight from the reference table. Biological carbon, stromatolites, oldest microfossils, Paleozoic, Mesozoic, Cenozoic, and 65.5. All right, we got 3 minutes. Let's keep going. So what happened? We had mass extinction of dinosaurs, ammonoids, and many land animals. This began 251 million years ago, and again, mass extinction of many land and marine organisms. 542, great diversity of life forms and fossil record. Quaternary, Neogene, Paleogene, Paleogene, Cretaceous, Jurassic, Triassic, Cretaceous. Permian, Carboniferous, Devonian, Silurian, Ordovician, and Cambrian. Pennsylvanian, Mississippian. Oh, looks like I didn't even finish mine. Sorry about that. Middle Devonian, late Silurian, early Cretaceous, middle Cambrian, middle Permian, Pleistocene, Quaternary, early Cambrian, early Silurian, and middle Ordovician. I guess I'll have to get to the answers for the rest of it tomorrow. No homework tonight.